Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.17. Read the scenario. Problem number 2.17. Find the average value of each voltage waveform in given below figure. There are four number of voltage waveforms given in this scenario and we have to find the average voltage for each case. So without wasting time, let's proceed towards the solution. We will start from this figure A. If we observe, this is the output of a half wave rectifier and we have to find the average voltage of this voltage waveform. So we know that in case of half wave rectifier, we calculate average voltage using this equation. In this equation, V peak of output waveform is divided by pi to calculate the average voltage of waveform. So in this figure A, the peak voltage is 5 volt. So 5 volt divided by pi will be equal to the average of this voltage waveform. Divide 5 volt with pi, the answer will be 1.59 volt. So the average voltage of this voltage waveform will be equal to 1.59 volt. Move towards second figure B. If we observe, this is the output of a full wave rectifier having the peak voltage of 100 volt and we have to calculate its average voltage. We know that in case of full wave rectifier, we use this equation to find out its average voltage. In this equation, we take the 2 times of peak voltage and divide it with pi to calculate the average voltage. So we know the value of peak voltage, that is 100 volt. 2 times of 100 volt will become 200 volt and divide 200 volt with pi to calculate the average voltage of this figure B, that will become 63.66 volt. Move towards third figure. In this figure, the output voltage waveform of full wave rectifier is shown, which includes a 10 volt DC offset value and we have to calculate its average value. In order to find its average value, first we have to find the peak voltage of this output waveform only. This waveform is starting from 10 volt and ending on 20 volt, which is the highest value of this waveform. So in order to find its peak value, we will take the difference of these two values, that will be equal to its peak value. V peak of this output voltage waveform will be equal to 20 volt minus 10 volt DC offset, that will become 10 volt. So the peak of this voltage waveform is 10 volt. Now in order to calculate its average value, we will again use this equation because it is also the output of a full wave rectifier. In this equation, we know the value of V peak, that is equal to 10 volt. So multiply 10 volt with 2, it will become 20 volt and divide it with pi. So the average of this output waveform will be equal to 6.366 volt. But this is the average of this output waveform only. We have not added the DC offset which was present in this waveform, that is equal to 10 volt. So in order to find the total average value of this complete waveform, we have to add 10 volt offset as well. Sum of 6.366 plus 10 volt will become 16.366 volt. So the average of this complete waveform is equal to 16.366 volt. Now we will move towards the last waveform. Again, this is the output of full wave rectifier, but now this waveform is starting from minus 15 volt and ending on 25 volt. So first of all, we have to find its peak voltage value so that we can apply this full wave rectifier average voltage calculation formula to calculate its average voltage. In order to find its peak voltage, we will subtract value of 15 volt from this 25 volt because the higher value of this voltage waveform is 25 and minimum value is minus 15. So the difference of these two values will be equal to 25 volt minus into minus 15. These two minus will multiply with each other and it will become plus 15. Plus 15 and 25 will become 40 volt. So the peak value of this output voltage waveform is 40 volt. Now we will use this equation to find out the average of this voltage waveform. In this equation we know the value of V peak, that is equal to 40 volt. So 40 volt multiplied by 2 will become 80 volt divided by pi will be equal to the average of this voltage waveform. Divide 80 volt with pi, it will become 25.465 volt. This is the average value of this voltage waveform, but we have calculated this value with respect of this reference 0 volt. But the actual waveform is starting from minus 15 volt, so we have to subtract this minus 15 volt from the average value of this waveform in order to find out the actual average voltage of this waveform. That will become 10.465 volt. So the average of this voltage waveform, whose minimum value is minus 15 volt and maximum value is 25 volt, will be equal to 10.465 volt. So it was all about exercise problem number 2.17. Thank you. See you again in next video.